Hello everyone and welcome to presentation about blockchain facts, myths and challenges. Let me go through the process of how I'm going to present this this presentations and this information. I'm going to go through the cases of explaining first what is the blockchain technology and then advancing into the facts and the myths and the challenges facing blockchain as a technology as we speak. A little bit about myself. My name is Professor Ahmed Banafa, and I teach at two universities here in the Silicon Valley, San Jose State University and College of Engineering, and at the Continuous Studies of Stanford University, where I teach the blockchain and the cybersecurity classes. I'm a media expert in technology in the Bay Area and appearances on multiple channels, NBC, CBS, and Fox, and ABC, and two other channels, the Spanish-speaking channel and the Chinese-speaking channels, and the local NPR affiliate channel, and also the local radio stations. I studied the cybersecurity at Harvard University, and I studied digital transformation at MIT, and my education is in electrical engineering, graduate and undergraduate. I published a book in 2018 under the name of Secure and Smart Internet of Things using blockchain and AI, and the book now is on the shelves of famous universities, Stanford, Berkeley, Princeton, and Harvard, and also lately Yale added that one to their shelves, and the Library of Congress also added the book. Last month, the book won an award at San Jose State Annual Author and Artist Award. For the technical books at the College of Engineering of San Jose State. Okay, in 2020, my goal is to finish and publish my book. It's going to be available probably in the first in January, in the first month of 2020. Now, before I go and dive deeply into the blockchain itself, I always like to go through the filter of the hot technologies in 2020 and beyond. I call them the IBAC, which is running from the Internet of Things to blockchain technology to artificial intelligence to cybersecurity. The four technologies are actually the four tracks of technology here in Silicon Valley. You will find so many companies, so many startups, all what they do is actually hitting one or two of the categories we mentioned. Either they're working on a case of Internet of Things, or they are running the other three, from blockchain to artificial intelligence to cybersecurity. And this is what I tell my students: if you'd like to focus your research and study, just pick one of those areas and find so many of the topics available there, and then focus on a topic that you can find yourself good at. In another way of making the IBAC as a concept clear and make more sense for people is to use the human terms. So IoT, Internet of Things, fields, blockchain remembers, and AI thinks, and cybersecurity protects. So this is one of the things that I use all the time, just to make the concept clear to everyone. Now, the internet, as we know, is actually built around the concept of connectivity, which is bringing everybody together. All what you need is a phone number or Wi-Fi hotspot, and you're in. This is the concept of the internet. Now, if you compare that one to blockchain, you're going to see that blockchain is built on enabling trust between partners, between nodes, between computers that they don't know each other. They're actually trustless nodes. And that's the whole concept. If you keep this in mind, it's easy for you to understand where we're going to go with this presentation when we talk about connectivity and we're talking about trust. Many universities is actually teaching the concept of blockchain, but they teach it under the concept of cryptocurrency, because cryptocurrency is the first thing that we heard about it before we even know that blockchain is the underlying technology for that. So you can see a lot of universities, from Princeton to Harvard to Berkeley to MIT to Columbia to Cornell to Stanford. You can see so many of the big names. They approach the blockchain from the concept of the cryptocurrency, but nowadays it's actually that's a different story. This is like 2 years ago. Nowadays, you're going to find that a lot of those companies, a lot of those universities, they have a specific track for the blockchain. They have a whole course just dealing with blockchain from perspective of the introduction or the technology to the next level, which is the development of the platform. The blockchain itself is really a big source of attention for so many of the investments. It's about you can see that a lot of investment here in the Silicon Valley. The infusion of cash is big in the Silicon Valley for the blockchain. The same thing goes with when we talk about New York, because that's related to the finance, and then after that when we are talking about the rest of the world, how they look at the blockchain investment. If you divide it by the country, you're going to see that the United States is 40% of the investment is coming from the United States, and then after that, when you go to China and you go to the UK and Singapore and the other, and South Korea and the rest of the countries, there is really a big understanding and a big focus on blockchain in the United States, but it's evolving. And this is you see this one by the week, you see this one by the month, when you are really following the progress of blockchain. Gartner, the big IT firm, they estimated the blockchain will generate about $3.1 trillion 10 years from now. So within 10 years, the business value, which is saving, adding, increasing the productivity, saving in the cost, increasing the profit, saving any kind of loss that you could have without the technology, is about $3.1 trillion by 2030. But what is blockchain itself? Blockchain itself is very simple, to concept. Approach it with an open mind, and it's very easy for you to see how it's really helping people, to implement that technology. So blockchain is a software. That's what it is. It's actually a program. You write that program, and this program will be integrated within your network, within your infrastructure, and it will serve one purpose, which is secure the transaction, secure the records you have. So if somebody asks you what is a blockchain, the first thing you should tell that person is a software, and that's gonna lower down all the anxiety and the concern about this is like some kind of a black box. You can enter the information, nobody knows what's going on. If you look at the formal definition of blockchain, you're gonna see it is in Wikipedia. It's a little bit twisted. It's a lot of terms there. I leave it for you guys and ladies to read it on the screen, but this is not what I'm looking for. This is not the definition I use, or I explain to my student. The best definition for blockchain actually came from a professor from MIT. His name is Professor Abel Sanchez, and this is how he explained it. He said that the blockchain technology is a combination of two things: the cryptography, which is the encryption, plus the human logic, which is the consensus protocol, the agreement between among that node. I'll give you an example, and use this example in all my presentations about blockchain. If you have a building, and this building has 100 people working in that building, and there is a security guard at the door, and that security guard is checking your ID when you're trying to enter the building. That's all what the person needs to get in. It's just show them your ID and you're in, and after that one I can do whatever I want. This is the current situation we have. This is the centralized client server concept of username, password, and you're in. That is not what blockchain about, because you can fool that person. You can play games, against that person. You can you can manage to manipulate that security and get in. In the blockchain technology, and the blockchain technology story is different. The security guard will have a list of names and pictures. So if you're in, they're going to look at it and check you're in, and if not, they're going to tell you no. In the blockchain world, everybody in that building will have a copy of the same list the security guards have, with names and pictures. So even if you manage to go through the security guard, then everybody in the building will be looking at you and say, do you see that person? Do you see their name is there, their picture is there? If over 51% of the people say, oh, no, we don't see that person, this person will be out. And that percent, 51%, is something you predetermine when you reject any kind of information which is not right. If the person's name and picture is there, that person will stay. So now you have everybody there have the same information. Now imagine if I would like that person would like to manipulate everybody in the building. The minute he or she try to approach the first, the second, the third person, everybody knows now that this person is really trying to do something wrong. So they're going to shut down that person and ask that person to leave. And this is the whole thing about the human logic. And the cryptography is the username, password, the ID, you have the name and the picture. The consensus is the human logic. So if you keep this in mind, it's easy for you to understand what is the blockchain. The 5 components of the blockchain are the cryptography, the encryption, peer-to-peer connectivity, consensus mechanism that we just explained, the ledger, which is that piece of paper that have the names and the pictures, and the validity rules, which is you have something called smart contract, which is we only allow people to get in from this time to this time. You can only get to the second floor, not the third floor. So those are part of the rules that you can add to the component of a blockchain. Now, if you never seen the cryptography before, which is the encryption, and the blockchain use the SHA-256 encryption. And this is just an example of it. You have the input in text, you do the hash function, which is the encryption function or program, and you get the hash sum, which is basically the encrypted message. And the length is the same. Doesn't matter what will be the input. Why and how and the blockchain itself, how it's really secure, how it's really can help people have the information without being altered. If you look at the block 0, which is the first block, you're going to see that there are data, there is encryption or hash, previous hash, timestamp, and index. This is whatever you store in that program. After you enter this data, all the information will be encrypted and added to the next block. And the same thing will happen to block number 1. It's going to be encrypted, all the information added to block number 2, and so on. So if somebody changed anything in block 1, everything after block 1 will be different. Because if what you are looking at here on the screen is just one node, there are at least 1,000 copies of exact information copied in other computer, and they sync with each other through something called gossip protocol. So if somebody changed something in block 1 by saying I'm sending $10,000 instead of sending $500, when they sync, they say, wait a minute, the block number 1 is different. The same thing block 2, you're going to say wait a minute, the information I have encrypted is not the same as the one you have here. So there will be some kind of check for the blockchain. And this is the strength of the blockchain, is the distributive fact of trustless node communicating about an information and making sure that the information is the same. And this is an example of a programming of blockchain. You can see if you notice, that's exactly the same thing we had in the previous slide. Timestamp, transactions, previous hash, all of these things is mentioned here. Programming used for blockchain is C++, which is the building block for the Bitcoin, Python, JavaScript, if you want to connect this one to the web, Solidity, Solidity is a program for smart contract created by Ethereum, and it's really a good one that you should learn if you are really into this kind of technology, and Java and Go, program language. There are 3 tracks for the blockchain in the valley, at least in the valley. The pure R&D track, like what happened in universities. Immediate business benefits, 2 sub-tracks. The first one is understanding the technology. The second one is applying the technology. The third one is the long-term transformational potential for the blockchain, which is something done by the venture capitalists. They see what's next after the blockchain. Types of blockchain, we have 3. We have the private, public, and we have something called federated or hybrid blockchain. The private one is a company like IBM, which is very famous of building the private blockchain network. Go to the company has 10,000 employees. They're going to say pick 1,000 computers. Those are going to be the nodes for your blockchain. Public is like Ethereum, Bitcoin, all of these are public. You just download their program and you're part of the network. Federated and hybrid. Hybrid is private and public. Certain part will be on the private blockchain, and certain part you can do it with the public one. The federated is different. The federated is if you have banks, and those banks, what they have different network with similar customers, so they can exchange the information about the customers. Important to know that the blockchain itself is actually came out of old technologies. And if you look at the next slide, you're going to see that you're talking about 6 technologies that paved the way for the blockchain. Public key, peer-to-peer. All of these things happened in 1999, in 1970, in 1970s, and 1993, and 1994. All of these things in 1996 when you have the process of virtual machine. All of these things, all what we have done is just we recycled, rehashed the whole old technologies, brought them together, and now we have a new technology called blockchain. The good news and the bad news: in 2018, LinkedIn they labeled blockchain developer, the programmer for blockchain, as #1 emerging job, that it is up by 33 times. Not 33%, 33 times. And in 2018, there was a survey for the CIO of companies, and they found that the implementation only 3.3% in the world for the blockchain technologies. But that's good news. Why? Because this is actually proof that the blockchain is just entering the growth cycle in the product life cycle. If you took marketing, you know what I'm talking about. In marketing, the product life cycle has 4 stages. Those 4 stages is the pioneering, the growth, the maturity, and decline. Pioneering is the introduction. And then now we finish from the introduction. Now we're getting to the point we are getting into the growth. In 2019, as we are really closing the year, Ernst & Young have a wonderful, insight, a perspective about the blockchain. We moved from explain this to me to prove it to me. We moved from the PowerPoint presentation into the pilot programs. And that's what happened to the blockchain. Now, in order for you to apply the blockchain to your company or to your activities or your institution, find which use case will fit the type of business you have. When I explain this one to business people, I tell them, okay, listen, you look at this slide and tell me your business is doing any of 2, 3, or all of the above. Your business is guarantee and verify data dissemination. Your business is doing product tracking. Does your business do an asset transfer? Does your business do a certified claims? If you do any of them, then the blockchain will help you in this case. Now, do you need it? Do you need it for real? Now, I have this slide, and I don't know if it will be big enough on the screen to show you, but this slide is really answer this one, like a check mark. This slide, you go and answer the questions in the bubbles, and based on this one, you will have one of 3 answers. You don't need it because you can do it with a simple database. You need it, but you're going to have a private, which is permissioned, or you need it and you can do it with a public blockchain. And and this is how we look at it. I mean, if you answer those questions, you will get to the stage where you say, okay, now I understand. I need the blockchain, or I need. It's expensive. Skills, implementations, programming. You have to really find your niche here, saying yes, I need it because I say yes to the following questions. The difference between the database and the blockchain is really big, and I'm going to go over this one very quickly just to make sure that the time is really not running out of me here. The blockchain is the peer-to-peer decentralized distributed ledger. Database is actually a centralized one. Authorities, for the database you have the admin. For the blockchain, you don't have any authority centralized. Architects, you have the database is using the client server architects, while in the case of the blockchain, we are using a distributed ledger network peer-to-peer connectivity. Handling the data itself for the blockchain, what you do is you read and write. You cannot change it. If it's there forever. You cannot change it. Even if it's wrong, it stays there. For the case of the database, you have the famous CRUD, which is create, read, update, and delete. Integrity, highly integrity and information on the blockchain compared to the database is always a victim of malicious actors accessing them. Transparency, it shows you the transparency. Why? Because you can see all the encrypted information going back and forth. For the databases, the admin will decide who see what and when. The cost, expensive. for the blockchain, for the database, is very, very cheap, and technically speaking, it is free. For in some cases like SQL, you can download that database. Blockchain is watered down by the verification. It's slow because if you notice that you have to verify the information with every node, and if you have a lot of nodes, that's going to take a lot of time. That's going to be a lot of time for this. Databases are extremely fast and great for scalability. Now, some of the applications for the blockchain, which is, I'm not going to go over all this one. I mean, I'll leave it on the screen so everyone can see it, but you can see that it's covering almost the whole spectrum of the business, from IoT, Internet of Things, digital trading, proof of ownership, escrow, digital identity, and so on. It all started with this paper by Satoshi Nakamoto. I have to learn to say his name correctly. So Satoshi Nakamoto. Nobody knows if this is a person or persons, he or she, or an organization. But on October 31st, 2008, this person or persons published this paper about peer-to-peer electronic cash, the Bitcoin. The progress of blockchain, or the blockchain history, goes from the 1990 all the way to 2019, which is the implementation stage we are talking about. That is how it's really progressed from, and each milestone there, from the smart contract to the applications. Stack of the blockchain is really an interesting for anybody who's trying to develop a startup, or a student who would like to find something to do a research in. So you have the internet connectivity to the blockchain. You have what happened inside the blockchain itself as protocols, from the token to the mining to the node to the consensus, and to the application layer, from the smart contract to the dApps, the decentralized apps, all the way to the user experience and the desktop applications, smartphone and tablets. Cryptocurrency, which is not going to be the topic of us here, but just have to mention it because this is really a big part of talking about the blockchain. This is just a survey about which country has the highest ownership of cryptocurrency, and you can see that all the countries with a high percentage. Facebook has actually fighting to have their own cryptocurrency. They have something called Libra. And Libra itself, and just to compare it with the dollar and with the Bitcoin, the dollar is the currency of the state, the Libra is the currency of the corporation, and the Bitcoin is the currency of the people. So they have their own cryptocurrency. And they used to have they have this organization called Libra.org, and they have some of the companies, big names, but some of them just quit, bail out, like Visa and Stripe and eBay and MasterCard and Booking and PayPal. All of them just dropped from the organization lately. Now, what's the best definition for Libra as the cryptocurrency of Facebook? Libra is something between Bitcoin and PayPal. It is a cryptocurrency without fluctuations or speculations of the Bitcoin, and it is a payment service without the fees of PayPal. If you use PayPal, there are actually fees associated with that. In order for you to start the blocks and generate the first block and to add the information, we have to distinguish about which node will do this one. The top famous protocols used is proof of work and proof of stake. Quickly, the proof of work is you solve a mathematical problem, and if you solve that problem within 10 minutes, you get that fractions of bitcoins, and you start the blocks. That takes a lot of energy because you have to use a lot of computing process and graphical processing units, and it's actually used a lot of power. And I'm going to show you in the next slide what does that mean. So, if this is an example of a mathematical problem, I would like you to find, a hash function that starts with 3 zeros. I don't give you any seed phrase. You start from whatever word you have, and you keep trying and try and try and try and try until you find that. And you see that person, he tried or she tried with a statement and add one, and keep trying until they find that if you add this number, they're gonna get the 3 digits, 3 zeros in the encryption. That takes a lot of power. And this is just an example of Bitcoin, how much electric power is actually consumed by Bitcoin. It's actually the third in the world when it comes to the consumption after China and the United States. So that one is the case of the proof of work. Proof of stake is we look at who has the highest number of bitcoins, highest number of cryptocurrency in the network, and we ask that person or persons, we can rotate that and ask that person to start the process, because it's in their best interest to that the network is functioning and no problems, and we take a portion of the stake or of the cryptocurrencies of that person as a collateral. We keep it as a security deposit. If that person did anything wrong, then we take that deposit and we ban that person from the network forever. So that's proof of stake. No power here. You don't have to solve any problems. It's a matter of just assigning some percent. There are so many other protocols that it depends on your situation, and this is also a very rich area for research for the students. Proof of work, proof of stake, proof of assignment, proof of authority, proof of burn, proof, you name it. All of these things part of it. The best architects of the blockchain is what you see here in front of you. Similar to what we have on the OSI model in computer networks when you're talking about the 7 layers. Now we have this thing here, you can talking about those 6 layers, and you talk about it, you're talking about the application layer, service layer, and each one of them has its own definition of the concept. The soft fork and the hard fork is a concept in blockchain that is very important to keep in mind. That kind of technology is helping you to correct mistakes or to start a new change in the blockchain. The soft fork is like an upgrade. You still have other computers have the old operating system, they still function, and you have the one with the new one, and then they catch up eventually with them. So if there's a soft fork or forks, the nodes that is not upgraded or did not upgrade or have not upgraded to the new specs, like increasing the size of the transaction, adding more fields, then they can watch what's going on, but they cannot participate. That is once they upgrade, they're part of the process. For the hard fork, no. Hard fork is either you upgrade, you're out. You have to upgrade now. And this is the thing about the hard fork. We have 2 cases of hard forks in the industry. One of them is the Ethereum and Ethereum Classic. The Ethereum and Ethereum Classic is a hard fork, and the Bitcoin and the Bitcoin Cash. Both of them the same thing. They are hard forks, and you can see that each one of them has their own symbol in the stock market. They have their own pricing, and this is because they are completely different technologies or different size of the blocks. Some of the challenges that facing the blockchain is the 51. If I can convince 51% of the people or the nodes, then I can change the information without any problem. And the rest of the things, this is something we talk about it, like the criminal activities associated with cryptocurrency. Something like the double spending, which is somebody can run the same application or the same transaction in 2 nodes at the same time. It's like you deposit the check in, at the same time you try to deposit check using your phone. More challenge is the scalability. So scalability is a problem because of the case of the nodes that you have to sync with, and you can confirm processing time, processing power for all this information, the storage, which is not a big problem now, but it's going to be in the future. Regulations, big problem. A lot of banks, they look at this one as a threat. Public perception about blockchain is Bitcoin. Skilled staff, we don't have them. And the first mile and the last mile problem. The first mile is garbage in, garbage out. Whatever information you're going to feed to the blockchain, it is the same information. The blockchain, the software is not going to verify that for you. If you say I'm going to send $200 to X, then I'm going to say no, just send them $100. Whatever you put there, and it is fixed. Once in the blockchain, they never change. Because if you change it, you're defeating the whole purpose of the blockchain. The last mile is after you receive the information outside the blockchain, things can change. Now, the current solution is, very quickly, is the Hyperledger, which is the one that done by IBM. That can do a throughput of 2,000 transactions per second. And then you can see that the Quorum, which is the competition for the Hyperledger, the Ethereum, the Ripple, and the R3 Corda. You see that the number of the transactions per second is very minimum. You have 1,500, you have 2,000. You can go to up to 3,000, but that's it. And this is not enough for companies like Visa and MasterCard, because Visa and MasterCard, they required the minimum of 24,000 transactions per second so they can use your system, and the blockchain cannot do that. Smart contracts and the languages used for smart contract. This is something that you consider if you'd like to dive into this technology. And the applications. There's so many things we can talk about the application. Just remember that the two categories of the blockchain is actually the record keeping and transactions. Some of transactions is the active and record keeping is the passive. So you have the passive way of just having the records and you're done, and transaction, which is goes with the with the real time. Some of the applications of the blockchain is the application of blockchain to the Internet of Things for all the four stages of the Internet of Things, from the sensors to the network to the platform to the applications. It's going to verify and make sure that it's the right person who's doing that. A lot of companies as an enterprise or enterprises using blockchain. You can recognize some of the famous names here, like corporations, startups, protocols, platforms. All of these things are part of it. MIT is one of the few universities that apply the blockchain to their degree, where you will have a copy of your degree on your phone as part of your graduation, and every employer, every company that would like to hire you have to be member of the blockchain network of MIT, and just show them that app with the QR and they can download your transcript and your information, and it's verified that nobody cannot change it. IBM is using their food trust network in many organizations, especially with Walmart. Walmart is deploying this one to many of their stores, where they can track back from where that food or fruit came, if there is a poisoning, if there is any kind of problems with the food. The other one is that for advertisement, it's used for advertisement to verify the number of the users, so nobody can claim that I have 1,000 impression or 1,000 views, while they look at it as, no, this is views from the same 5 views from the same person. How can you verify this? And there are ways for you to do this, and this is under something called proof of view. And if you remember, we talk about proof of stake, proof of work. There's something called proof of view, which you can verify that this person is the right person. And supply chain. Supply chain is a big applications for the blockchain. You start with the blockchain by documenting everything. Once you document it, it's settled. It's there. Nobody can change it until it gets to the destination. Starbucks is using blockchain. DocuSign, which is a signing document online company. Ticketmaster, to fight the fake tickets that people are selling, is also using blockchain. In Jordan, they have a Syrian refugee camp that use blockchain to identify people there, because they leave their country without any identification, and there is no way for you to distinguish among all the people there. Also, the return drug is a big problem in the United States. Drugs mean the medications. It's about 2-3%, about $10 billion losses for the companies. They have no idea if this is their medication coming back to them or not, because if they're not selling if the pharmacies of the places not selling the medication, they have to return it back, and they get their money out of that one. So they use the blockchain to verify this one using SAP. This is the big company. So Merck and SAP have a partnership, and they're using an app, and this app will verify the medication using an app called ATTP, Advanced Tracking and Trace for the pharma. And it's actually used the famous numbering for the GS1 standard. It's a very well-known standard for labeling. Insurance using this to eliminate invalid claims and reject multiple claims for the same accident. Real estate, they will have all your information stored in a place where if you want to buy a new property, if you want to change, if you want to rent, they don't have to submit the documentation again and again. It is saved. It's the same. It's on the blockchain. All what they're gonna just go and grab that information, and you can add the new information about if you have a new job, if you have new kids, if you move somewhere else. All this information can be added. Okay, some of the threats to the blockchain is quantum computing, and this is recent. This is very recent when it comes to that. Quantum computing is a big threat for this one. I wrote an article about that on LinkedIn. You are more than welcome to check that article. Is quantum computing and blockchain facts and myths. So the biggest threats or danger for this one for a blockchain network is quantum computing, because it's going to break the encryption. it's going to break the traditional encryption, then you get a problem with that. Now, Google has actually announced that they have something called the quantum supremacy. Quantum supremacy, that what they have done is they reach a certain level of calculations that usually done in thousands of years, they did it in seconds. For example, they said that the quantum supremacy announced by Google, they said a calculation that normally done by computer and that calculation normally take more than 10,000 years. They have done this one in 200 seconds, and that is the definition of the quantum supremacy. Now, Google supercomputer has the ability of or they consist of 52 qubit, which is like the bits we have, the zeros and ones. In order for you to break the encryption of the internet or encryption of the SHA-256, you need 1,500 qubits. So we're a little bit, few years until we get to that. So at least 5 years, we'll save until we find a way for us to save the current encryption for the internet. The answer for the quantum computing is something called quantum cryptography, which is using light instead of using the electrical signals and zeros and ones. The shift in cryptography now is going from math, which is the SHA-256 and all the zeros and one, to physics, which is the light, because you're using the photons in this case. And that's the new shift for that. And this is where the direction for the encryption will be, which is using physical concept, the concept of physics, to secure the communication instead of using the mathematical calculations as what we have now in encryption. Okay, so I'm done with the presentation. If you have any questions, I'll be more than happy to answer that. You have my LinkedIn link, and you can join me or you can follow me on Twitter. Thank you so much.